We've recently released Maple 2018 and we always pack a lot into each new version of Maple. In this webinar I'm going to introduce a selection of some of the most significant new features. Let's start off with the context panel. The context panel changes the way that everyone interacts with Maple. You may remember the context menu in older versions of Maple. With the context menu, you right-clicked onto math and up popped a context-sensitive menu that gave you relevant mathematical function. We've moved that functionality plus many other tools into the context panel, and I'll show you the context panel in action in a minute or so. It appears on the right-hand side of the Maple interface, and it offers a far more discoverable, a far more intuitive way of using Maple's functionality. So let's take a look at the context panel. Now, if I click on this arrow here, we see the context panel. And if I just start typing in an expression, let's start off with something simple. I see relevant mathematical functionality, relevant options appearing in the panel on the right-hand side. So this is a far more accessible, far more intuitive way of using Maple's broad math functionality than the older context menu. So once I've got my expression, let me apply mathematical operation to it. Let's plot the result, and there you go. The mathematical operations appear in line and are fully documented as well. We've also moved other items into the context panel as well. So you may remember the clickable math pop-ups as well. These are actually moved here into the context panel right at the very top. If I click on one of these, Maple performs the mathematical operation. So the context-sensitive menus are truly context-sensitive. If I select a differential equation, I have new options appearing. From these options I can solve the differential equation symbolically. If I select or enter a transfer function, I have a new dynamic systems menu here at the very bottom, which allows me to generate phase plots, magnitude plots. Let's select phase plots. If I select a matrix, I can extract eigenvalues, eigenvectors. I can perform statistical analysis on the data in that matrix and much more. Let's try importing an audio file. And I'll do this with the import data assistant. So within Maple we have a number of audio files that we distribute with the product. I'm just going to point to one of those. Let's try this one. So there's my data file. There's my audio file, and now you can see I have a new signal processing menu here. From that signal processing menu I can generate periodograms, spectrograms, perform signal processing on the audio file, and much more. We've also moved Maple's tools for formatting units into the context panel as well. So here's a mathematical operation with a unit associated with it. This is the result. If I just left click on the result, I can change the unit of the result. I can also apply some level of number formatting as well. If I've inserted one of Maple's UI components, such as a slider, dial gauge widget, or a button into my interface, if I just select that UI element, I can access its properties here on the right hand side. So for example, I can change its orientation. I can click this button and change the action code for that UI component and much more. I can also change table properties from the context menu. So as you can see, as I'm doing different things in Maple, the context panel changes its content to reflect options which are relevant to what I've clicked on. So here I've just deselected or disabled the display of the table borders. Now there's another really useful feature of the context panel, and that's the plot builder. This was something that we introduced last year, but we've enhanced its functionality. So if I just select this series of inequalities and select the plot builder option here, the plot builder pops up in the context panel. It intelligently leads me through the options I need to generate a plot. So here's a 2D inequality plot. I can change its visual appearance, the color scheme, the coordinate system, and much more. We can add in a title, labels for the X and Y axes, and other things. So that's the context panel. Now, I've been using the context panel regularly ever since we started developing the tool. It really has changed the way I interact with Maple. It's made me much more productive with navigating Maple, with discovering Maple's broad range of functionality. So let's talk about units. We've radically enhanced the scope and the utility of units in Maple 2018. Units can now be used in equation solving, optimization, integration, and many other tools. With older versions of Maple, we had to strip out units at a certain point in our analysis because Maple just didn't know what to do with those units. Now we can leave our units in from parameter definition through to equation solving, optimization, and integration, and through to visualization as well. And this is a simple example of the functionality. In this application, we're investigating the sag and span of a parabolic suspension cable. The cable length, L, is given by this equation. There are a number of parameters in this equation, including D, A, and L. Here I've specified values for L and D, and you should note that these parameters have units associated with them. And now I can put this equation into fsolve and ask fsolve to give me a value for the span. Let's just run this worksheet. And the result pops out with units associated with it. If I bring up the context panel, I can actually change the unit of the result to inches, centimeters. I can apply number formatting to the results, and much more. Just to show you another example of units, of the work we've done with units. In this application, we're calculating the work done in the isothermal compression of methane. So we're compressing methane from a specific volume of 1 meter cubed per kilogram to 0.5 meters cubed per kilogram. First of all, we define an expression which gives us the pressure of methane as a function of the specific volume, and this uses a command from the Thermophysical Data Library. V is the specific volume, and then I can perform this numeric integration, the integral of P dV between these two limits, to calculate the work done, and the result pops out with units associated with this as well. Now I can use units in many other tools within Maple, in the optimizers, the numeric equation solvers, the symbolic equation solvers, and much more. Let's talk about thermodynamic data. A few versions ago we introduced the thermophysical data package. This offered thermodynamic and transport properties of a range of pure fluids and arbitrary fluid mixtures. And for 2018 we've added the thermodynamic properties of over 2,000 more gases, liquids and solids. The data is in the chemicals sub-package in the thermophysical data package. If I click on this link, this will bring up a help page which gives an entire list of all the new chemical species in the chemical sub-package. There's lots of data there. And the functionality is fully integrated with our unit system. So here I'm extracting the molar enthalpy of ethanol at a temperature of 320 Kelvin, and the result pops out with units associated with it as well. What I can also do is return an explicit formula which gives me an empirical correlation for the thermodynamic property as well. So here instead of specifying a value for temperature, I've asked it to give me the temperature in terms of T and an explicit formula. And this is the piecewise function that defines the enthalpy of my chemical species. Now there's lots I can do with this data. This data can be used to study chemical equilibrium composition, reaction spontaneity, the performance of chemical rockets, flame temperatures, explosion and detonation pressures, and many other things as well. And we've developed a broad range of applications which demonstrate how you can use this functionality. So in this application, which is available on our application center, we're using the new data set to find the adiabatic flame temperature and equilibrium composition when you combust carbon monoxide in pure oxygen. We've used the new sub-package in thermophysical data to extract the heat of formation of carbon monoxide, carbon, oxygen, carbon dioxide, and elemental carbon. We've also extracted the entropies of those chemical species. We've then defined a few procedures which give us the Gibbs free energy of formation of carbon monoxide, carbon dioxide, and the other chemical species within the system. For any given temperature, you can minimize the total Gibbs free energy of the combustion products to give the equilibrium composition, and you can equate the enthalpy of the reactants and the products to calculate the flame temperature. You end up with a series of equations that you can put into FSolve together with the units of all individual parameters, and then Maple will calculate the adiabatic flame temperature and the equilibrium composition of the combustion products. There are many other applications that we've uploaded to our application center that demonstrate the utility and scope of this functionality, and they're all available to download and browse free of charge. With 2018, we've given you more ways of protecting your code from prying eyes. Normally, if you write a procedure or a program, anyone can look at the code even if you save the code into a package or library archive. For the new release, we've added the ability to encrypt procedures. This means that others can use the procedure, but they can't see the actual code. So how do we do this? Well, all you do is add a new option encrypted, to your procedure definition. It's right there. And then you save the encrypted procedure to a Maple library archive. This just saves it into an MLA file that you can send to your clients and colleagues. Your clients and colleagues can then use that MLA to use the procedure in the MLA. However, if they try to view the contents of the procedure, they just see something like this. It's undecipherable encrypted code. We've also given users the ability to specify applications, tables and worksheets as non-editable. So if you look at the bottom of my worksheet, I have a new checkbox which allows me to specify that a worksheet is non-editable or editable. By default, all documents are editable, so this is always checked. But if you deselect this, that means the entire document is non-editable. However, you can still change parameter values in any UI elements. You can still click on buttons and UI elements to get updated results, but you can't change or delete any of the code. If I try to change the text, Maple won't allow me to do that. I can't delete or move any of the UI elements either. Let's talk about interpolation. The new interpolation package helps you to make predictions from real-world data that's typically unstructured and irregular. And here's a simple introduction to the functionality. Think of something like weather stations randomly dotted around a region, each of which is recording the temperature. So here I think I have 1, 2, 3, 4, 5 weather stations, each at their own latitude and longitude, scattered randomly around a region, each of which record the temperature given here, right by the location of the weather station. To predict the temperature at an intermediate point, you need to use specialized interpolation techniques. So let's say that I want to predict the temperature at this point at a latitude and longitude of 55 and minus 170. Well, I can do that with the new interpolation tools. The new package is called Interpolation, and it offers a number of techniques for structured and unstructured interpolation. So here I've specified the location, so the latitude, longitude and temperature at all of my known weather stations. I then use the interpolate function from the interpolation package to generate an interpolating function using a kriging method, and then I can predict the temperature at a latitude and longitude of my choosing. So here I'm predicting the temperature at a latitude of 55 and a longitude of minus 170. So I can actually take this one step further and use the new interpolating functions to do more advanced analysis and visualization. Here I've used the new interpolation techniques to generate a smoothly shaded weather map. So here I have far more weather stations randomly dotted around the US. Each of those weather stations records the temperature. Using the interpolated temperature, I can then generate a smoothly shaded weather map. And this application is again available on the Maple Application Center. There are a number of options you can change. You can change the coarseness or the smoothness of the shading. You can change the region of the US over which you generate the weather map. So there's lots you can do with this application. Here's another application which uses the new interpolation package to generate a smoothly shaded ternary plot. So I know the result of my model of my system at these individual points here. So here specifically I know the break energy of my ternary polymer blend. Using the interpolation package, I can predict the break energy at any intermediate points and use that information to generate a smoothly shaded ternary plot. So there are many interesting applications of unstructured irregular interpolation in science and engineering. One application is in FEM, finite element modelling. A single FEM simulation might take a few hours to run, so often, but it's far more efficient to run a limited number of FEM simulations and then use interpolation techniques to predict the response at intermediate points, and that's typically known as meta-modelling. Let's talk about some of the improvements that we've made to our connectivity. Maple's a very open system and we offer connectivity to many other tools. We translate Maple code to other language, and we give users the ability to use Maple as the math engine in your own code base as well. With Maple 2018 we've extended that story. Maple 2018 now comes with a full Python kernel. This means you can issue Python commands and run Python scripts from within a Maple session. So everyone who installs Maple 2018 has access to a Python interpreter. So if you load the Python package, as I've done here, you can issue Python commands, you can import Python modules, and the selection of Python modules are actually shipped with Maple as well. So here I use specific functionality from the beautiful soup Python package to do some HTML parsing. As a non-trivial demonstration of what this functionality will do for you, we've actually programmed in connectivity to TensorFlow. That's a Python framework for machine learning, and this is offered in the new deep learning package. Machine learning and deep learning is a very active, vibrant field with many fascinating applications, and this is just something that we've prototyped using the new Python connectivity and the new deep learning package. In this application we've trained a neural network using machine learning techniques to recognize some handwritten digits. So these are our training images. They're handwritten digits for the numbers 0, 1, 2, 3 through to 9. We then train our admittedly simple neural network to recognize the image, and then we can import test images, test handwritten digits, and try to predict the numbers signified by those digits. So this is the image 5, and the neural network correctly predicts that the number is number 5. There are a few hiccups, so apparently the neural network thinks that this handwritten digit is the number 5, but it does a fairly good job of predicting the value of the other handwritten digits. Let's talk about coding in Maple. We've made many substantial improvements to code editing in Maple 2018. We've made it easier to write, debug, and maintain your code. And I'm just going to start off with a really trivial example of how we've improved code edit regions. And this may not seem like a big feature, but it's really improved the quality of how I use Maple. What I can do is now use the arrow keys to go in and out of code edit regions. So previously I had to use the mouse to navigate out of a code editor region, but now I can do that with the arrow keys on my keyboard. There's a few other improvements that we made to coding in Maple. Now we have automatic command completion. So if I just start typing in a command, I see command completion automatically appearing. I can hit the tab key to complete the command, and so on. So the code editor is used to implement action code for the UI components. And the startup code region. We've made a number of improvements to that. So we've improved the ability to detect errors in code that you enter into the startup code region or the action code in your UI components. Let me show you what this looks like. So as I'm writing code, you see parsing errors appearing immediately into this box here. So now, although I haven't made any syntax errors in this procedure, Maple's still given me some advice about how I can improve my code. So it told me that I haven't explicitly declared this local variable b here in the parsing errors box. Here Maple told me that n has been declared as both a local variable and a parameter. And I've also assigned a value to b, but I haven't used it anywhere in my code. Let's talk about the improvements that we made to Maple's tools for doing math. Fundamentally, this is the core reason why many people continue to use Maple year after year, the fact that it offers continually improving leading edge tools for doing math. There are many improvements that we've made to the core math functionality in Maple, and what I'm going to show you is just a selection. We have a number of new packages. There's a new package for doing computational geometry. So here I've generated a Rono diagram from a series of randomly generated data points. I also have tools for doing a conval hole analysis, Delaunay triangulation, polygon triangulation and more in the computational geometry package. We have tools for manipulating dates and times as well. So we have a new date object within Maple, and it's declared with the date function. So here I'm creating a date object with a year of 2017, a month of 12, and a day of 25. I can also do things like change the time zone as well if I want to. I've declared another date object. I can subtract one from the other. There's a new calendar package which allows me to calculate things like differences between two dates, the days of the week, the days in a year, and more as well. We've enhanced the graph theory package so there are more built-in graphs. We've also made performance improvements as well to this functionality. We've made vast improvements to our tools for solving PDEs and ODEs symbolically. We've also improved our core tools for basic symbolic math such as integration, differentiation. the bread and butter of Maple as well. So this is a previously unsolved example. Now there are many other enhancements that we've made throughout the entire Maple system. We made improvements to the physics package. There are more tools for educators to better teach their students. We've made other improvements to the user interface. Our website actually offers far more detail, or if you already have Maple 2018 installed, I'd suggest browsing the What's New material.